Okay, so let's go ahead and see if we can figure this one out. Again, this was optional, but I want to at least show you the solution. So to start, like any of our other problems, we've got to write down what f of x plus h is, just replacing x with x plus h in the original expression. Again, not real difficult as far as finding out what that is going to be. We know where that's going to go, right? That's going to go right here, and then f of x will go right here. So now it's just a matter of rewriting. So we've got our derivative is f prime is the limit as h approaches 0 of f of x plus h, which is just 1 over x plus h, minus f of x, which is 1 over x, all over h. Now, there's a lot going on in this problem. I'm going to go ahead and work on the numerator, and we'll slowly start to put this together. Here's what I know. My goal is to try to figure out a way to get rid of the factor of h in the denominator. That's my goal, because then I can substitute in a 0 for h. Can't do that yet. So what I'm going to do, my only real strategy here, is to try to combine those two fractions to make them 1. Now, to do so, we've got to be really careful about how we approach this. I need a common denominator. So in order to get common denominators, I need to have the same set of factors in both fractions in the denominator, which means I can multiply this first fraction by x over x, multiply the second fraction by x plus h over x plus h, and now I've got common denominators. So let's see what that looks like when we start putting this all together. Okay, so in the numerator, if I look at so there's two parts to this. We have this big fraction where the denominator is h, but we have this smaller fraction in the numerator here where the numerator's denominator, that sounds funny, is x times x plus h. Now, in the numerator of that fraction, we're going to have 1 times x, which is just x, minus, and then we'll have 1 times x plus h, so minus x plus h. Okay, that doesn't look too bad. Let's see if we can simplify this even more. Once again, I'm not going to go through a second step here to get rid of the parentheses in the top there, but x minus x we know is going to be 0. Now watch, this is minus h here. So we're really saying negative h over x times x plus h. Now, guys, I want to pause here for a second. In this step here, we know that we have a fraction divided by a fraction. Think of this as h over 1. Part of the process that we've done a lot this year is taking a fraction divided by a fraction and rewriting it as a multiplication. So I can take that as the multiplication times the reciprocal. Now that's nice because look, now I have this giant 1 of h, which is beautiful because look what's left. We have the limit as h approaches 0 of, now that's negative 1 in the numerator, over x times x plus h. We no longer have a factor of h. We have a factor that has h in it, but we don't have a factor of just h. So now we can go ahead and plug 0 in for h. And when we do so, we get negative 1 over x times x plus 0, which is just negative 1 over x times x, which, oh, that's just x squared. Okay, so our original expression was f of x equals 1 over x. The derivative was negative 1 over x squared. And again, we'll look at that in the next lesson.